exercise 1, let that load here. It says count, actually, wait, there it is. Okay, so this is the exercise 1, right? Fractions, count 2 of 5 parts equal. I mean, I believe this is just asking you to write 2 over 5. And you're just taking the two numbers from the written expression. So that's kind of how it's starting out. It's moving towards like, how do you add, subtract, multiply, simplify fractions? Those would be more of the questions I would think you would be unsure about.
Like the how to simplify them sort of thing?
Yeah, or compare them. So that's what, so I would suggest kind of moving into a different part of this packet rather than going from page 1, but that's your call. Please tell me what we should do.
Where are you going to start? Like the end of this?
No, let me go to, just to be clear. Yeah, like this exercise number 3. This is a good place to start with fractions. It's because you know how to write them, you know that it's division. And these are the exercises to reduce fractions. So I'd like to start here if that's okay with you.
Yeah, that's good.
Okay.
Dude.
So I'm gonna rewrite number 1. Number 1 is 6 divided by 8, 6 over 8. So you always start with 2, and you just say, well, can I divide both of these numbers by 2? And the answer is yes. 6 divided by 2 is 3. 8 divided by 2 is 4. Okay. Now you stop when there's no more numbers that work that divide into both the top and the bottom. And that's what's hard to figure out. It's like, when am I done?
Yeah.
Okay. The answer is if you know your prime factors and you get 2 numbers that are on this list, but I think you know that 3/4 is a place to stop.
Yeah.
So let's look at number 4 next. Okay. Number 4, we'll look at the other ones as well. Number 4 says 8 divided by 10. You always start with 2. Just ask yourself, is 8 divisible by 2?
Yeah.
I can't, go ahead.
Would it um, would it stop there?
Yeah, 4 over 5. You stop when you get a prime number. And in this case, 5 is a prime number, so you know to stop. You might also just look at this and say, yeah, there's nothing else that works in there. Right. Let's look at number 2 now. Number 2 is 12 divided by 15. You start with 2 and you realize, okay, 12 is divisible by 2 because it's even, but 15 is not. It's odd. So we go to the next prime number, which is 3. Is 12 divisible by 3? Is 15 divisible by 3? And the divisibility rule for 3 is if you can add up the digits, so like 1 plus 2, if that's a multiple of 3, 1 plus 5 is 6. If that's a multiple of 3, you know that they're both divisible by 3. So in this case, 12 divided by 3 is 4. 15 divided by 3 is 5. Now, I can't remember, are you allowed to use a calculator on your test?
After a certain point, I'm not entirely sure because some people will be like, oh, like you don't know which ones, but from what I've heard, it's like the beginning, like maybe 10 questions.
Okay.
Like it's they put them all at the beginning, the ones you can't use a calculator for, I think. And I think it's like basics sort of
Got it.
stuff.
Yeah.
I
Okay.
would have to look again and see. I wonder if they have.
Yeah, thanks for reminding me. So I will keep that in mind as we're moving through this. So the next problem we should look at is number 5 here. 6 divided by 12. You always start with 2. You always start with 2. And since they're both even, you're like, yeah, 2 goes into both of these numbers. 6 divided by 2 is 3. 12 divided by 2 is 6. Okay. And you might look at that and you might, say, okay, I'm done, or hey, no, maybe there's a little bit more to do here. 2 does not work anymore because 3 is odd, but 6 is even. So you go to your next prime number 3. And both of these numbers are
So
divisible by 3. Sorry, go ahead.
It would it be half
Yes.
because it's 3's half of 6?
Yes. And you might have recognized that from the beginning, like, oh, 6
Mm.
divided by 12, that's half. That's okay too. You don't have to show all this work. You just have to get to the final answer, whatever method you like. All right, so let's look at number 6, 16 over 24. Same thing. Does 2 work? Does each of these numbers divide evenly by 2? Yeah, they do. 16 divided by 2 is 8. 24 divided by 2 is 12. And you always try the number again. You try it until it doesn't work anymore. I mean, that
So I
applies.
just keep going by 2, like,
Yeah.
because 8 and 12 are both divisible by 2.
Yes. And then you try it again. Just like real life. We try something until it doesn't work anymore.
So it'd be 4 over 6.
Yes.
And then could you do anything else with that?
You can divide them
Yeah.
both by 2
Because
again.
you can
You
put,
keep trying, keep trying, keep trying.
so it'd be
And you
2
get,
over 3.
yes. Okay, so there's a few more problems we can look at in exercise 4. Let me grab the ones that I think are probably going to be a little bit more challenging for you to look at or think about. So exercise 4 is just more fractions. I think we should look at a problem like number 2, and maybe one of these other bigger numbers here. So number 2 is 80 divided by 100. Now you can divide by 2, but when you see something matching on the top and the bottom, you should cancel it out. The zeros in this case. Whenever you see a 0 on the top and the bottom, you can cancel it out.
So I would do like 8 and 10.
Yeah, and then you can say, oh yeah, let me divide by 2, like we've been doing. If you try to divide by 2 from the beginning, it's a lot of writing. And you're wondering, like, why am I doing this? There must be a better way. It's a reasonable question to ask. Okay, so 4 is 400 divided by 5,000. You can cancel out the zeros if they're the same on the top and the bottom. If you have a colored pencil, it's always good to kind of designate that a different color. Here you divide by 2.
So it would be 4 and 50.
Yes, I'm getting ahead of you. I apologize. Yeah, and then you say, well, can I divide those by?
I'm not sure at 50 divided by 2 would be. I have to put it on.
It's 25. So for some of these like divisions and multiplications, there's a ton of games on your phone, the App Store to find, just something you can spend a few minutes on each day to get faster at these math facts. I mean, that's all they are. And the whole goal is to get faster for this exam. All right, is there any other ones in this list here that you would like us to look at? Any ones that I'm sure they all look awful, but is there one that you're like, I would have no idea how to do that, or be unsure of how to start?
Do you always start with 2?
Yes, always.
Do you do them all these the same way?
Yes.
I think
Like,
what about?
like 11 is non-obvious. It ends up being 1/3. They're both divisible by 17, and you probably wouldn't know that right away. That was the only one that sort of came to mind as being a really odd one here when I was looking at this list.
So could you not get to that by 2?
No, because 17 is odd, 51 is odd. You would strike out with a bunch of numbers. You would not be able to divide either 17 or 51 except by 17. But all the rest are pretty reasonable. 2 or 3 go into all of them.
how do I know when two won't go in if they're both odd numbers?
Yeah, so like, let's look at number 8. Let's look at number 8 here. So number 8 says 63 divided by 81. They're both odd, so 2 doesn't work. The divisibility rule for 3 is that you add up the digits. So 6 plus 3 is 9. 8 plus 1 is 9. And these are both multiples of 3. So that means they're both divisible by 3. Now, as a reminder, if you're not sure how it works out, you can do the long division. You can put 3 outside the house, the 63 inside the house to divide. This is the way you would have learned it the first time you learned division, and it's okay to use it here. Like, it still works. 3 goes into 6 2 times. 2 times 3 is 6. Bring it down, subtract. It's 0, so you bring this 3 down. 3 goes into 3 1 time. Is that something you've seen before, that long division that's familiar to you?
Yeah.
Okay. Same thing with 81. 3 into 81. 3 goes into 8 2 times. 2 times 3 is 6. You subtract 2, bring the 1 down. 3 goes into 21 7 times. So you try 3 again. You hope that it works and that it keeps working, because if it keeps working, you just do it. So 2 plus 1 for 21 is 3. That's good. And 2 plus 7 is 9. That's good. That means that both 21 and 27 is divisible by 3. So you can again divide those by 3. And these numbers are a little smaller, so you probably remember that this is 7 over 9.
And is that one?
What is your question? Is that one done?
Yeah.
Yeah, and I know that's hard. It's like, well, when
Okay.
is it done? It's done when you get down to a prime number in the top or the bottom. These are some prime numbers to remember. No one likes fractions, so it's just to keep persevering here. Do some of these practice problems on your own. Do you have the solutions to these at the end, or is it just problem sets?
Let me check because
Oh yeah,
it took the teacher from the other class a while to send this out, so I ended up
no, it's
not being
there.
able to look through it
Yeah,
until okay, here it
it's
is.
there.
Yeah, they
Yeah,
have
it's
the
there.
answer key.
That's good. So the only thing you don't get is the explanation. But I would try some on your own. I think you know enough now to try a few of these on your own. We can move on to comparing fractions. It looks to be the next topic in this list. Is that okay with you?
Yeah, comparing fractions where
Yeah.
stuff.
So let me, we're going to do exercise 5, but before we do that, I want to just give you some simple examples. Okay. Some things you probably already know. So 8 over 9 and 5 over 9, which is greater, which is smaller?
8/9 is bigger because it's more of
Yes.
the base number.
So when the bottoms are the same, you look at the top, right? You just figure out, well, which number is bigger, which number is smaller. Okay, and that's a fairly straightforward recipe, but the problem is you're going to get something like number 1 here. Let me snip this in, where the bottoms are not the same. Let me snip this in. So you're going to get a problem like this, and you got to be like, well, you got to figure out what goes in here. So to do this, you make a common denominator. Okay, so our common denominator is going to be 16. And we'll talk about why in a moment, but Just go with that for now. What do you multiply 4 by to get 16?
4.
4. So you end up multiplying the top and the bottom by 4. So that becomes a 12 over 16. You bring the other numbers down, and then you can make that comparison. You can say that this is greater.
And how do you get 16? For
On the
bottom?
right or on the bottom, on the left here?
On just for the bottom, because isn't that how you finish it?
Yeah, well, this is all you have to do. You have to just decide which one is bigger. I'm kind of leading you through this without telling you why we make it 16, other than we want to make it the same. I was going to do another example just to see if you could follow the steps here and then give you more explanation. Is that fair?
Okay.
Sometimes you just want to know what to do and not know why it works. So here's a problem here. You want to figure out what goes in the middle. Is it greater than, less than, or equal to? What I notice is that 5 goes into 10. Okay, like 5 can become 10 if you multiply by 2. Do you agree with that?
Mhm.
But you have to multiply both the top and the bottom by 2. So on the left here, the top is 2 times 2, which is 4. The bottom is 5 times 2, which is 10. And now you can compare the fractions.
So would you just change them to whichever one's bigger?
Generally, yes. Generally, you go that direction. Okay, so let me have you try one here on your own, or you can ask me questions. But yeah, this would be greater than. You generally go to the bigger one. That's a good observation. Okay, so here's a new problem for you. It's not always that the left one becomes the right. In this case, you want to turn the 8 into a 16. What do you do to the 8 to turn it into a 16?
You multiply it by 2, and then you would turn the 5 into a 10 on the top because it'd
Yep.
be 5.
Very good.
And then they'd be equal.
These are equal. So I think from what I heard just now is you understand what to do if like the one goes into the other.
Yeah.
Okay, but that's not a realistic problem, unfortunately. The more realistic problem is I give you something like this. 3/4 and 5/7. And we want to know which is bigger, or are they equal?
Don't you have to figure out which is the smallest closest number that both those denominators divide equally into?
So
And then, or
yeah,
no?
well, yes, like many of those words were right on. I'm going to show you a specific way to do this. You're going to take this bottom number on the left and you multiply the 2 numbers on the right by that bottom number. And this leads to adding fractions, by the way. That's why we're doing it. So on the right, it becomes 20 over 28. Then you take this bottom number on the right and you multiply it by the 2 on the left. And what you notice is that you now have the same denominator.
So do you just like cross
Yes,
multiply every time?
pretty much. You take the number from the bottom left and multiply it by the other 2, the number on the bottom right, multiply by the other 2. But you only do that when they don't go into each other. So this one, it's not obvious, but it's greater than now that you see that. So let's do another one here. That's okay with you.
Mhm.
So let's go. Is this helping? Is this working for you, this format, what we're doing tonight?
Yeah, because I have my computer, so I can like draw stuff on my computer too.
Nice. Okay. Let's go. 2/3, no, 2/7, 2/7 again. This isn't right. Let me make this, sorry, I'm struggling to come up with decent numbers, but let me make, let's go 5 and then we'll do 4 here. That'll make more sense. Okay. These are unlike denominators. 9 and 7 are unlike. You cannot make the 7 into a 9 or a 9 into a 7. So that's the case where you have to, like you said, you kind of cross multiply. You take that bottom number there on the lower left and multiply both numbers on the right by 9. And this is where you got to be really strong with your multiplication, your math facts there. Then you take that number on bottom right and multiply both on the left. Now it's always the case that you should get the same bottom because 9 times 7 is the same as 7 times 9. But the number up top will be a little bit different. Is that okay?
Yeah.
So this becomes a less than. Now this leads nicely to adding fractions. Okay, so I'd like to move to adding some fractions. Your book does some estimating, some other stuff, which we can come back to, but I think it would be good for us to add because it's a really misunderstood topic. Excuse me. Or do you want us to go to, yeah, let's just do that because I really do think you'll get this. So this is the classic adding fractions problem that a student gets first time. Okay. And when you add fractions, you have to remember to make a common denominator, just like we did in the last couple of problems, common denominator. So, we didn't have the plus symbol here. We were comparing them. To make your common denominator, you take this 2 on the lower left, and that's what you multiply both of these numbers by. You take this 3 on the lower right, and you multiply both of these numbers on the left by that. And this gets you your common denominator. It's 3/6 plus 2/6. Okay, and this is
then you would just add the top two numbers.
That's right, and you keep the bottom. Add the top, keep the bottom. It's not difficult when you know the steps. You have to make a common denominator though. Very, very, very important. You cannot do this without making a common denominator. Okay, so let's look at another problem here. Let's say, sorry, make sure you got that. Did you get this down?
Yeah.
Okay. If you need more time, just let me know. Let's say I wanted you to add 2/3 plus 3/4. So the denominators are not the same. 3 does not go into 4 and 4 does not go into 3. So this is the case where you have to multiply the numbers together. You have to make a common denominator. So on the right, you would multiply by 3 because of this 3 on the left. And then similarly, 4, you multiply both of these numbers by 4. You should always get the same bottom. It's 12 on the bottom, 8 plus 9/12. What does that add up to?
17/12.
Yes. Now this is what's called an improper fraction. Improper fraction. The name's not really important, but your packet does seem to address this. It's improper because the number on top is larger than the number on the bottom. So whenever you see that, it's considered an improper fraction.
I kind of remember doing the improper fractions and the mixed numbers. Isn't
Yes.
it like you do you divide the top by the bottom or vice
Yes,
versa?
yes, exactly.
The top by
Top,
the bottom, and then whatever the remainder is the base number, something I don't remember which
that's
is
right.
which,
No, you
but
said it correctly.
yeah.
Yeah. So 17 divided by 12 is 1, and then the remainder is 5 over the bottom number.
Okay, so I remember how to do that because I remember there being something to do with like when I went through the GED book like years ago for the first time,
Mhm.
I had trouble with I remember it was something with fractions where it was easier for me to like like to do it one way and then like basically go back and forth between a mixed number and improper fraction until I can't remember exactly what it was, but I remember a point where it was easier for me to um do it in one form and then switch it over.
Yeah, you should do the form that makes the most sense to you to work it out. And we'll, whatever you're comfortable with. It's math, you do get choices. It's not always like, hey, do it this way, do it that way. Okay, let's try another problem here. Let's do a subtraction problem. Let's do 4/3 minus 1/2. Okay, so just like the previous problem, we don't have a common denominator. We have to make one. And hopefully by now you just can say, oh, it's times 3 times 3. On the right, on the left here, it's times 2 times 2.
So it's the same, even with subtracting, you still times
Yes, yes.
two.
What's different though is you subtract the top numbers. It's now 8 minus 3. Keep the bottom.
It's gonna be 5/6.
Yes. So you got to be careful though. Like sometimes we overcomplicate problems. So I'll give you an example here. Let's say I want to do 1/2 minus 3/10. So the way the brain works is if you've been doing something one way long enough, you just immediately say, oh, it's times 2 times 2 times 10 times 10. And while this works, it is not the right way to do this problem. The right way to do this problem is to recognize that 2 goes into 10. If you
No, if
multiply, sorry, go ahead.
okay. I was saying so you should check if the bottom ones can multiply into each other first.
Yes, yes. Because it saves you time and it saves you from having to do additional work at the end. And I could show you that, but for now, just go with it. The left side here becomes 5/10 minus 3/10, which is 2/10. Now, this is the first problem where you now have to know to reduce this fraction. Like, even though this is correct, it wouldn't be on the answer.
Because it would be reduced.
Yes, exactly.
Would you just you would do it by 2? Okay, so it would be 1/5.
Perfect.
And is that where you would stop it, right? Because
Yes,
it's a
yes.
prime.
That's a prime. 5's a prime. One is neither prime, but that's not
Yeah,
not
it's just
important.
one.
Just one. Okay. So here, let's try one here. Let's go do one more here. 2/5 minus 1/7. Could you try this one on your own, please?
Okay. Is it 9/35?
Yes. Okay. Well done. So on page 33 of the PDF, there is a bunch more of these to do. You can probably be good for you to look at those at some point later on. It's the exercise 4. That helps. But now I think we should talk a little bit more about those mixed numbers and going the other direction. So here's a new problem that's kind of related. It's like, what is 5 1/3 plus 2 1/2? Okay, so there's actually a couple ways to do this. One is to convert these both to improper fractions. So I'd like to do that just to see if you remember. Well, that's not written very well. There we go. Okay. Do you remember how to convert 5 1/3 to an improper fraction?
Kind of.
You take
You add two of the numbers and then like either divide or multiply them
so you take
by.
you take the 3 times the 5, and
Okay,
then you
so you.
add the 1. You kind of go, if you can draw a little path here, it's kind of that direction
Okay.
through the numbers. It's 3 times 5 plus 1. And then you keep the bottom number. So it would be 16/3. Same thing on the right here. It's the bottom number times the number in front plus the top number.
So that one would be 5/2.
Yes. So now to add them or subtract them, it's the same situation we had before. You have to make a common denominator. It's really just like the problem we've been doing. You have to be able to make a common denominator. So the numbers get a little bit larger. Can't help that. Times 2 times 2 times 3 times 3. So that's 32/6 plus 15/6.
And then you would turn that back into a mixed fraction.
Maybe, like if they wanted you to, of course. So why don't we do that just to see if that's clear. You got to figure out how many times 6 goes into 47 first of all, and then figure out what the remainder is.
Okay.
So 47 goes in, 6 goes into 47 7 times, and maybe somewhere off to the side, you'd write 6 times 7 is 42. 47 minus 42 is remainder of 5. And then that 6 always comes with it.
You always keep the bottom, you always keep the
Yes.
denominator the same? Okay.
Yes.
And then it's just the answer is the top and the remainder is the whole number?
The remainder is that 5.
Oh, the remainder is the numerator and the
Yes.
answer
Yes.
is the whole number.
Yes. Well, I mean, it's all the answer. I mean, like just to, I'm not trying to parse your words, but everything is the answer. I mean, this whole thing is what you would see on the multiple choice.
I mean, like the answer from the
Division.
division question. Yeah,
Yes.
like the answer before the remainder of what goes
Yes.
into it. And
Yes.
that's the whole number.
Yes. So like I think you heard me say earlier, there was really like 2 approaches to doing this type of problem. I recommend always doing the improper fractions. There's an approach where you work with the whole numbers and then the fractions, but it leads to a few other cases. We can go through that if you would like, or we can just always do it this way.
I can go through because I don't remember how you do it with the mixed numbers at all.
So what I'm saying is like, do you want me to show you the other way to do this or?
Yeah.
Okay, let's do the same example because this one's okay. There's nothing weird about this one, but then we'll do one where it isn't. So when you have two mixed numbers, you first look at the whole number part. 5 plus 2. You're like, oh, that's 7. Then you look at the 1/3 and the 1/2 and you add those. Okay, now you still have to make a common denominator. Okay, so you would multiply the left by 2, the right by 3, and you get 2/6 plus, excuse me, 3/6, and that's 5/6 together.
So it would still be 7 and 5/6.
Yes. Okay, and that looked really good. You're like, well, why wouldn't I always do that? It's
I don't.
probably,
Well, this
go
one
ahead.
was an easy. This one was an easier one with
Yes.
the numbers, but I
Yes.
think it was subtracting them, which is the one. It was subtracting mixed numbers, which was the one that I was having a big issue with, I think.
Yes. Yes. And actually, none of the ones here are. They're actually here's one. Here's one. Number 7. Let's look at this. All right, so this one is 5 1/6 minus 2 1/3. All right, so you take the 5 and the 2 and you subtract those, and that's no big deal. That's 3. But then you got to know what to do with the 1/6 minus the 1/3. Okay, and this is that case where the 3 goes into the 6, so you don't
So
multiply them both.
you
Sorry.
just make it 2, so it would just be like that. Okay.
Okay. And you're in great shape. You're like, all right, 1 minus 2, that's -1. Okay. So the problem is you cannot write your answer as 3 and -1/6.
Yeah, that
Okay.
doesn't make sense.
But what you can do is you can say, well, 3 is really, and this is where, this is where it's the exception. It's really 2 plus 1.
Yeah, this is where you borrow from the.
Yeah, you say, oh, and 1 is really 6/6. And so 6/6 minus 1/6 is 5/6. And
Yeah,
there's your final answer.
I
So
don't really get that.
yeah, and that's why I don't recommend this approach. I would never use this approach because the way,
That's the one where I would always change it to
yeah,
improper
yes.
and do it that way.
And you can always try it. You can say, well, let me try it. And if it doesn't work, or if I get down to something I'm not sure about, then I go back and do it the other way.
And that way seems like it takes it, where at least for me it would take pretty much just as long, because I felt turning them into the improper and then turning them back, it feels like it takes a little longer, but it's not that difficult, like if you have a calculator to just switch them back and forth real fast,
Yes.
and I understand them better. And I'm assuming the questions that I'll have, these, at least the more difficult ones, will be past, at least I'm hoping they'll be past the
Yes.
section, so I'll be able to make it a little bit faster.
All right. So the next type of problems we should look at are multiplying fractions and dividing fractions. These are taught at the end because they're pretty straightforward. So
Actually, I think I remember a little bit, but what?
You multiply the tops and you multiply the bottoms. This is just an example. 1/2 times 4/5. You multiply the top numbers, you multiply the bottom numbers, but you have to know to then reduce your final answer.
And that one you would do 2
Yes.
for 4 and 10, so it would be 2 and 5.
Good.
And then you couldn't reduce that any further?
That's right. So let me give you another one here. So here's another fraction that it would say, to multiply as an example. So you multiply the tops and then you multiply the bottoms. Not to be confused with adding, right? It kind of looks like adding, but it's not. Top is 30, bottom is 30. What does that reduce to?
Would that just be a whole? Because it's 30 out of 30? It would just be
Yes.
one?
Yes, exactly. That's really good that you know that, you've seen that. So the only like challenge with those is that the numbers can get kind of large. So you got to know your multiplication tables. But we'll look at division next. And I'm going through the multiplication quickly because division really is multiplication. You'll see that in a moment here. All right, so here's a problem. It says 2/3 divided by 5/6. So you always change division into multiplication of what's called the reciprocal. You have any idea what I mean by reciprocal?
Is that just the product of them all? What does that
So let
mean?
me show you here. So the 2/3 stays the same. The division becomes a multiplication, and then you flip. Flip is probably a better word. You flip
Oh,
the
okay.
fraction. So it becomes 6/5.
So you don't really have to divide at all.
No, you never divide. You
Okay,
never,
good.
ever, ever, ever divide. And then you multiply the tops, and then you multiply the bottoms.
Okay, that's really easy.
But this is not done. This is like if you were to give me this in a classroom, I would say,
It's
nope.
not reduced.
Yeah, that's right. So
You'd start at 3, right? For
3
this
does
one, or
work.
no?
Yeah, very
Because
good.
they have 3 and 6 is there.
Let's try another one here. All right, here's another problem. So you never, 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 ever divide. You always change the division into multiplication, and you take the reciprocal.
Hold on. So you flip it and then you multiply it always, and then
Yes,
you just
always.
so it'd be 4 and 4/6.
Yes.
And then
But then
could you reduce that at all, or no?
yes.
Could you?
Yes.
Oh yeah, just 2. 6
Yeah,
just 2.
your
I forgot
intuition is
6 just 2.
your intuition is right. You know, like you said, man, it looks like it kind of, yeah, sort of. Yes. Would you like us to do one more problem or stop here?
Could do one more problem.
Okay. All right, so this one's gonna be a little bit bigger in terms of the numbers, but it's the same process. You never divide. And I'm repetitive because I mean, you need to hear that. You never divide. Like you're like, oh, it's always multiplication by the flip. Right? Now, there's a couple of ways to do this part of the problem. You can multiply the tops and you can multiply the bottoms. But you can also try to cancel. And this would be the next kind of topic to get into. But like 5 goes into 15 3 times. Have you seen that before?
The canceling?
Yes.
Yeah, that always confused me a little.
Okay, so let's not do that for this problem. Let's just straight multiply these, and you'll see that the numbers get a little large, but it's totally doable here. 5 times 16 you'll find is 80, and 8 times 15 is 120. What should we do with the zeros?
Cross them out, and then
Cross them out.
that makes it a lot easier because then 8 and 12.
And so you said you didn't know anything about canceling, but you just did it. You actually do know. You're gonna be all ahead of schedule here. So it's 8/12.
And then you would do that by 2, right?
Yes.
So it'd be 4/6, and then you could also then do that by 2, and then that would be the end of it.
Yes. All right. So